All right, folks. Thanks for joining me here. Excited to be in this session. Um, if you heard Coinbase and you thought I'm going to talk about the future of Bitcoin and how to mint crypto riches, you're probably in the wrong session. I'm not doing that today. Um, but if you want to hear about how we took a clunky machine learning workflow and made it fast, scalable, more pleasant to live with, that's what this session is about. Hopefully, there'll be a few takeaways that you can take to your teams. So I'm going to specifically talk about, like I said, a duct-taped but critical machine learning workflow called the unban system and how we rebuilt it on Snowflake. And we did it with a couple of really talented data scientists on my team. One of them, Summer, is here. And with the help of the Snowflake team. And we did it without, a team of PhDs in distributed systems or 7-tab browsers open for debugging. So I'm excited to talk about that. So quick intro about myself. My name is Tuhin Ghosh. I lead up data science for the platform product group at Coinbase. I've been at Coinbase for a bit over 3 years. So that in crypto years is long enough that I've seen a few things, is one way to put it. All right, for those of you who are maybe not familiar with Coinbase, just to reiterate what our mission is to increase economic freedom in the world. That's a bold mission, but what that means at its core is to give easy and seamless and trusted access to the next billion users to the crypto economy. And behind the scenes, data plays a big part in ensuring that good users, legit users, have seamless access and lock it down against bad users. All right, so this is what I'll try and cover today. I'll give you an overview of the platform product group. Like I said, I lead up data science for the platform product group. So I'll set the business context, what exactly the business problem was, what the machine learning workflow is, and then talk about why our existing machine learning infrastructure wasn't quite cutting it for this specific workflow, and then how we got introduced to Snowflake ML, our journey implementing it on Snowflake, and then end with a few next steps for us. All right. To start with, let me just give you a quick overview of what it means to be the platform team at Coinbase. So the platform team at Coinbase is essentially the backbone of the company. So we are the team. We are the team that's sort of ensuring that for the next millions, if not billion users as they show up on Coinbase, stuff still works. So that means we cover everything from onboarding to payments to machine learning to the whole blockchain ecosystem, all of that. So it's a pretty wide scope. This is the largest product group at Coinbase. So what that means is that we are doing things like we are onboarding users. We are making sure that you can make payments. We can authenticate users. We support all of the experimentation across the company, which means hopefully folks are not shipping risky changes. They are testing things, they're personalizing it, they're using machine learning. And then a really important aspect of our business is risk and liquidity. So we are in a highly adversarial domain where there are a lot of bad actors and bots that are constantly evolving, and it takes a lot of effort to keep up with that. So risk and liquidity, and then finally the blockchain ecosystem. So when there's stuff happening on the blockchain, be it 2 blockchains, 10 blockchains, we are the team that ensures that everything goes through smoothly. So a lot of this is underpinned by strong data fundamentals, data infrastructure. And so let me actually switch gears a little bit and talk about the specific business context for this machine learning workflow. So I told you about the platform product group. I told you about how we worry about risk quite a bit. Now what happens is that we have a lot of like systems which would, if they suspect that there is any sort of suspicious behavior, they will restrict accounts. So you as a Coinbase user could get restricted if we think that you're doing something suspicious, which looks fishy, looks suspicious. Now, every now and then, what happens is that a completely sort of innocent, good user also gets restricted because we think that they're doing something suspicious. And so you come to your Coinbase account, and you find yourself restricted. You quickly go down a rabbit hole of, did I break something? Did I get hacked? Etc. So we need a process for these restricted accounts to appeal the restriction, right? So you want to be able to appeal the restriction and have that ban removed from your account. Hence the unban system. Hence what we call the unban system. Now, if you imagine Coinbase scale, we're talking about tens of thousands of users who encounter this. I mean, despite our best efforts, tens of thousands of users who encounter this every year. So we need something that's safe. We need something that's fast and trustworthy. And we need something that's scalable, right? So as you can imagine, we cannot look at appeals coming from tens of thousands of users just through human review. So this is a perfect setup for a batch machine learning problem. So, you have all of like the data, which is actually in Snowflake. You have the data on user behavior. You have the data on past human agent decisions. That's all sitting in Snowflake. So as you can imagine, and you don't need to do this real time. This can be done once a day. So it's a perfect setup. The one thing that you have to sort of be concerned about is, like I said, risk is a highly adversarial domain. Things change very rapidly. So you're looking at deploying systems which can be retrained, refreshed very quickly. So that setup, so like I said, it's a perfect setup for machine learning, batch machine learning. It's an adversarial domain. And so when we set up like the machine learning workflow for the unban system, we first try to leverage our existing machine learning infrastructure. Now, a quick word about why that didn't quite work for us. So the existing machine learning infrastructure, which by the way is used for most of our ML models which are in production. So the way it works is most of our data is in Snowflake, but when you have to train and deploy a model, we send that data on a bit of a field trip, right? Most of the times, it goes from Snowflake to Databricks, where the rest of the pipeline lives. We'll use Tekton as a feature store. For our job infrastructure, we'll use Ray and Anyscale. We'll use RayServe for serving. And then, for all the experimentation, we'll use MLflow, and then Fiddler for observability. So it's quite the sort of alphabet soup. Now, this is not a critique of these tools. I mean, they're powerful. Like, if you're using Ray and you're into, distributed training of really large models, Ray works well. But from a humble data scientist perspective, this is a bit of I don't know what the right idiom is, using a machete where you really need a scalpel. So what we started exploring, I want to say about a year back with the Snowflake team, and maybe some of these capabilities existed, but we wanted to run this workflow close to where the data is, right? So I think in our experience, from a data scientist perspective, when you want to set up training of machine learning models and deployment of machine learning models, there's maybe 3 key components that you need, right? So you want a feature store, and we wanted a feature store which would seamlessly integrate with the data where it sits, right? So that was one part. And you want to be able to write the features in a language that is accessible to analysts and data scientists. The second piece, of course, that you need is you need to be able to have version control on models. So for every model, you want to have a sense for how it was trained, when it was trained, what features were used. And then finally, like model inference without doing a whole lot of like, hey, copy pasting of like taking the model file, etc., not worrying about like the scalability of the infrastructure, and having the results land in a way where they can be easily consumed for any downstream use cases. So we were introduced to Snowflake ML, and then what we did was like this specific unban workflow that I was telling you about. So the three maybe intuitive steps that you have for the three obvious steps that you have for training up the model and deploying it. The first part was, of course, like the training data sets. So like I said, the data was already in Snowflake. We had structured data on user behavior. We have agent decisions. We have chat transcripts. All of that's already sitting in Snowflake. We are already pretty comfortable with the governance setup that we have in Snowflake. We like that. So doing feature engineering within that context, where the data is, within the confines of the governance that we're comfortable with, no-brainer. And then like the other thing is that the feature refreshes. We don't have to worry about like babysitting any sort of orchestration, airflow jobs, etc. These happen automatically. The second part, of course, is like the model development. Most of us data scientists are, there's a few libraries that we feel pretty comfortable working with, like scikit-learn. All of that is available. And again, you're not doing any YAML marathons training the model. And then finally, when it comes to deployment, like these things are, because they are Snowflake objects, and then like the scalability, et cetera, is taken care of by Snowflake. So that's perfect for an analyst or a data scientist. So you don't want to worry about that part. The output is a Snowflake table again, and that can be then readily used for our downstream use cases. So we took something, in some sense, we traded complexity and maybe went from like complexity in the existing machine learning infra to something which was pretty simple and scalable and really works well for like data scientists at Coinbase. So finally, in terms of next steps, what we are looking at now is, now that we've implemented this for the unban workflow, we want to take like the typical use cases that the business uses quite a bit. Think of things like lifetime value prediction, again, like a batch machine learning problem, churn prediction for customers. We're taking each of these workflows and now migrating it to Snowflake ML from our sort of previous clunky way of doing things. We want to move it to Snowflake ML. We're also rethinking the way we have our data models set up. A lot of it used to be drop everything and rebuild from scratch. We want to sort of like, the way what we've realized is, for it to play well with Snowflake ML, we really want like incremental builds. And then rethinking our role-based access control so that we've used Snowflake extensively over the past few years for analytical workloads, right? So there's a little bit of like rethink required from a data platform side on how role-based access control will work on the ML side. And then finally, the reverse ETL aspect. Like I said, like a lot of these things will be output as tables in Snowflake. So establishing good patterns for how they get used in production systems.